Hi friends, let's learn about primer designing for quantitative PCR. So what you have to do is you have to open NCBI Primer Designing page. You have to just type NCBI Primer Designing. It will lead you to this page. Okay, now here it's written enter accession, GI or FASTA sequence. You have to uh, paste your sequence here if you want to make primers for gene sequence or CDS sequence. So for qPCR I suggest make on CDS sequence. So let's paste the sequence here in FASTA format. So I will select, I have pasted the sequence. I have the sequence in the FASTA format of Brassica rapa. I have pasted the sequence and I would suggest the minimum temperature to be 59 and maximum to be 65 degrees centigrade for primer melting TM, and uh, the size of the PCR product would be 70 to maximum 200. Don't make the product size greater than 200. And we have to select the organism. Since I have given the sequence for Brassica rapa, so I have to select the organism Brassica rapa. Okay, then let's proceed to find primers. So how many primers would you like to find out? That also we have the option, but first let's click on get primers. Now this will take a few seconds to few minutes, so we have to wait till then. So this page will appear and then your primers will be visible. Till then we have to wait. So it may take few seconds to like less than a minute, and it will give you the length of the primer and TM of the primer of the forward and reverse primer, the GC percentage. Now you need to know whether the primer is self-complementary or not. If they are shows high value on self-complementarity, then this means that there are the chances that they will self-complement. Okay, so we found several primer pairs, as you can see here, that forward primer, a primer pair 1 is this. So this is primer pair 1, where forward primer and reverse primer length and sequence are mentioned. The start and stop codon of this forward and reverse primer are mentioned. TM is 59 and 60, and GC percent, as we all know, it should be between 50 to 60%. So self complementarity score, the lower the better. So here it's 4 to 5 in self complementarity, and in self 3 prime complementarity is 3 or 0. So if it's within 4 to 5, we can consider this as a good primer. So likewise, as you have selected the number of primers you want, it will show the number of primers in the result. So I have selected 5 primers, so it will show me 5 primer pairs. So primer pair 1 is this. This is primer pair 2, and every time you will get the length of the product. Okay, so I would suggest only consider those primer pair where the product is around 150 to 200 base pair. Okay, you can while you are searching for the primers, you can select 10 sets of primers, but select how to select which one will go best for you, which one is the best set of primer. So for RT-PCR, I would suggest that consider the product size to be 150 to 200 base pair, and GC percent here it's perfect. It should be between 50 to 60%. and the length is also correct. The ideal length is 20 to 22 nucleotide. Okay, 1 to 2 base pair lesser or more would be considered. Okay, try to consider those primers which have lesser self complementarity. So the primers which are given by NCBI, they are good primers, but in these results also you have to filter the best one for yourself. Okay, keeping in mind the best conditions for primer designing. Number one is the length of the primer should be between 18 to 22 nucleotide, not lesser and not more. Okay, and the TM should be between 59 to 65. GC percent should be between 50 to 60%. Okay, and the lesser the self complementarity, the best the primer would be. Okay, so these characters you have to keep in mind. You have to select the best primers among the given sets, and then try to amplify, see if that works or not. So that's it about designing primers for RT-PCR.